Hi, welcome to Chem 1802 at Barton Community College, BART Online. I'm Dr. Kristen Hathcock, and this is my colleague, Dr. Amanda Alaband. We'll be completing the first experiment. It's exploring density. This is what you should be printing off when you complete this experiment. These are your instructions. We're going to walk you through the the materials for this, as well as parts of the different activities to help you get through the experiment in a timely manner. So the first thing we'd like to do is to walk you through the items that came in your lab kit and the items that didn't come in the lab kit that you have to provide.
You have to provide a calculator. These are very essential to have, so make sure you have one. They're lifesavers. Okay.
You also will provide plain old table sugar. You'll need to provide distilled or purified water throughout the course that you're taking this.
So if you get like a gallon jug, you can save it and then you don't have to go buy for each experiment.
Okay. I believe that is all you need to provide in here as far as, the soda.
Make sure it's regular and make sure that if it's a brand new bottle that you open the cap and let it go flat for 24 hours. So you need boring flat pop.
Okay. Now what comes in your lab kit are your scale, weigh boats, spoon, several spoons, several pipettes.
You'll have a grease marking pencil. You'll have a very small clear ruler. The cylinders that they are referring to in the materials list are these 3 cylinders here. They are found in this plastic bag. A 50 milliliter graduated cylinder, the plastic cups that are supplied in one of the bags, and as mentioned, the regular pop.
Okay, that's your materials list. And we're going to then walk you through the beginning activities. Please make sure that you pre-read your experiment. Thank you very much. And make sure you understand the background information that you'll need to do. Basically, know your definitions of what density are, mass, your formulas, and be able to create different solutions. Remember, mass times volume equals mass times volume.
And read these, if you read the instructions or the introduction before, that saves you a lot of time because they give you examples of equations, how to manipulate those equations, and it makes your life much easier knowing how to do those problems and those equations before coming to the actual experiment.
Okay, so we're going to do the first activity, and in the first activity, there's a separate document that you will record all of your information. And it's a Word document, and the Word document says exploring density. Okay, and here, activity 1, you're going to weigh all of your cylinders, and we're going to be talking about Archimedes' principle. Okay, so we need to obtain all of our materials, which we did when we identified everything for you. We're going to clean and sanitize our work area. So Dr. Alaband and I decided to go ahead and work in our actual chemistry lab. You guys will be working in your kitchen or in your dining rooms to make things a little easier.
So make sure that your children, any pets, they know to stay away from the chemicals, and you keep them away from your work environment.
Now, prior to starting this, after you've collected your materials, notice that Dr. Alaband and I are dressed appropriately for safety. Although in this particular experiment we're working with table sugar and water, some of the experiments that you will be working with in the future will have hazardous chemicals. Now, granted, the concentration may not be very high and they'll be diluted, they can still cause irritation. So Dr. Alaband and I have aprons on to protect our clothing. We have our hair pulled back. We also have on nitrile gloves.
And practice makes perfect.
We also have on our goggles. These are essential, what we call PPE, personal protective equipment, to make sure that we stay safe in the environment in which we're working. we expect that you will do the same.
All right, so the first part of, now that you've got your equipment set up, you're dressed appropriately, first part of this experiment tells you how to prepare your different sugar solutions. So we'll go ahead and prepare a couple of them, 0% and 10%. The 20 through 60% would be prepared in the same manner, but different amounts of sugar. Okay. So you have, I just pulled out all the different plastic cups that were available, and they say to mark one for beverage. So assuming that you should mark that one for beverage. Again, make sure that this is, it's got the carbon dioxide removed, so you've let it sit for 24 hours. And then we're going to prepare the following sucrose solutions, which we can do while this is sitting out, and so we have our sugar solutions prepared ahead of time. Okay. Now, one thing to make sure on a scale, okay, is there are 3 different buttons. It is backlit, so you do have a blue light, so you can easily see this. There is an on-off button, okay, so it's obviously off now that there is no screen. But you also need to be paying attention to the mode and tare button. Okay. So with the mode, there's some different units that you can use. Okay, make sure it's sitting on a flat surface so that you don't have the same issues that I just had. Okay, at the very bottom right hand corner you should see a G that tells you if you're in grams. If you're not, don't have that G, then you can have mode, and that'll take you through the ounces and the different appropriate units. So make sure that you have that bottom G. So if you need to, hit the mode button. Before you ever weigh anything, always make sure that you hit the tare button so that you standardize this back down to 0 grams.
Now, we need to take the weight of your weigh boat out, and so therefore, after you've zeroed it out, we're going to put the weigh boat on there, and we are going to tare it again. So that the weight of your weigh boat is already subtracted from the weight of the sugar.
Okay. So right now my balance is reading 2.35 grams. I'm going to hit the tare button, so now it says 0. All right, now, by mixing the indicated mass of sucrose in 50 milliliters of water or 50 grams. So density of water is something that you should be very familiar with. 1 gram of water equals 1 milliliter. So therefore 50 grams and 50 milliliters of water are the same because of the density. Okay. All right, so looking on the right hand side of page 6 towards the top, you have a percentage. So you have the sucrose percentages here. There's how much sugar. So in a 0% sucrose solution, you're going to add 0 grams of sugar and 50 milliliters of water, or 50 grams. A 10% sucrose solution, you would add 5.5 grams of sucrose and 50 milliliters of water.
So we'll go ahead and make one solution for you.
Now apparently your balance is on a timer, so you may have to reset this. Okay, but when I turned it back on, it is set for 0. But go ahead and make sure that it is 0. So when you are using the balance, be cautious that there is somewhat of a time limit that you have to work with.
Okay, I'm weighing out 5.5 grams.
And getting exactly 5.5 is a little tricky. So if you're 5 like we have 5.51, that's okay. Give or take a little, but don't go 5.5 and then measure out 6 expecting it to be okay.
So I'm going to take my cup and I'm going to label it. Labeling is very important. Without labels, you don't know what you're working with.
And while she's labeling, I'm going to go ahead and measure out the 50 milliliters of water. You want to read this from eye level. And you always want to read the bottom of the meniscus. So meaning that you want to read the bottom of that curvature. Now water, when you look at it, appears pretty flat, but you want to read from the bottom of the meniscus. So now this I can use for future experiments or the rest of these. Okay. All right, so I've got my 50 milliliters of water. I'm going to go ahead and add this to my 10% sugar solution. Okay. And underneath that table is an orange box that makes a small note about 50 and 60% sugar solutions. They're not going to dissolve real easily, so you're going to have to apply some heat, which it suggests using in a microwave. Okay. And so do this for 10 seconds each. Okay. So be careful what container you put your sugar solution in, because you don't want to melt the plastic. And to do it in a safe container. If you do it in these, no more than 10 seconds, but it should not take 2 minutes for that sugar to dissolve.
Now, if you're not going to use them right away, please cover them with plastic, and they're only good for about 48 hours. Okay, so that's how you create your 10% and above solutions. Okay, so that will get you started for the next activity, which is activity 2. You make those ahead of time. That gives you time to allow the sugar to dissolve in water. Okay, so now we'll be using the solutions to complete activity 2. We'll come back to activity 1 momentarily. So we need to weigh an empty 50 ml graduated cylinder, record the mass in table 2.
Okay. Now I do have water in this already because I just used that to prepare the sugar solution. Realize that you need, each time you do an experiment, you need to weigh this. If there's solutions in here, you need to weigh it each time, and so that you make sure that you're taking into account. So this 50 milliliter graduated cylinder should not have the same mass for a trial 1 or a trial 2. Okay? It needs to have a different mass each time. Now they should be somewhat close, but they should be different.
And they'll be off by probably a tenth, give or take, because there's only droplets of water left over. Mm-hmm. The average weight is around 30 grams for your graduated cylinder. Okay, so you're going to record the weight of your graduated cylinder in the third column here. Okay, so empty, it's around 30. Now it asks you to add 5 mils of water and record that weight.
Now, because I am accident prone, I am going to go ahead and take this off because I don't want to mess up that balance. So I'm going to, and make sure you understand what these markings mean. So each marking on here, on these, you see that it's separated by tens for markings. The middle one is your 5. So here's 10, there'd be 15. So each line in between is 1 milliliter. And don't do as I do and pour this back into the original solution. Now, since I know this was only water, that's not a big deal. But if there had been sugar present, then I have now sugar present in this water as well. And if you need to, you can use a pipette to help.
Okay, so we'll weigh the mass of our cylinder plus our solution. And we find that we're now at 35, approximately, grams. You'll repeat this process till you reach 25 mils You'll do this with each of your solutions. So we'll do it with the 10% solution, we'll do it with the 20, 30, 40, all the way up with 60%. You'll record that in this column here.
Now I'm measuring just water, so this is for the 0% sugar. Okay. Now to do for the
10%.
next column, I would want to reweigh this. Okay. And I'm still close to that 30. My balance is now saying 29.96, so I'm still right around that 30 range.
Okay, so
But for the 10% solution, since it is all dissolved, I would take 5 milliliters of this.
oh, what was the weight?
About 29.
29.94, okay.
Now I am doing the 10%, so I'm not doing the 0 like I did before. Now I did get a little too much. So these are really good, pipettes are really handy if you need to take small amounts out or add just a little bit. So I have 5 milliliters of that 10% solution. And go ahead and make sure each time that it is tared. And so with the solution, about our mass is 35.18.
Okay. And so as you can see, I recorded it without solution, with solution, and the difference will give you the mass of your solution. Okay. You'll repeat this process for your 20%, 30%, and 40%.
Yeah, so for the next one, instead of 5 milliliters in here, I would increase that volume up to 10, okay? Then up to 15, and then up to 20 and 25.
Okay. You will then graph that data with Microsoft Excel, and I put a video in your course shell for that as well. Okay, so that's activity 2. Okay, now let's go back to activity 1. Okay, in activity 1, we are going to use our balance here, and we are going to measure and weigh all of our cylinders. There are 3 specific cylinders. We have a silver, a clear, and a white.
There's the clear. They're not very big at all. The image on the lab may be a little bit misleading. So, but they are small, and again, you find them in that plastic bag. Just because these are all the same size, they should not have the same mass. Because again, these are different materials.
It's like, which weighs more? A pound of butter or a pound of feathers? All right, so using the balance, let's measure and weigh each one. Okay, so we're measuring, or we're weighing the white one.
So roughly 1.6 grams. Now again, yours is different. You're not going to have the exact same mass as what we have, but you should be somewhat close.
Don't forget your units.
Yes, units are very important. They help you understand what you're dealing with in terms of a size and quantity value.
So we're only going to do 1. We'll leave the other 2 up to you guys. Okay, so I weighed the clear one. That gives me my mass, 1.57. Okay, now we're going to measure its height.
Okay, so it's to measure it in centimeters.
Centimeters, okay. And it helps to have somebody help you out doing the recording. You've got family or friends that want to partake.
It's like 1.2 centimeters.
So the height is 1.2 centimeters, okay. The diameter, so a diameter is the entire length
And these are a little hard to hold on to.
from one side
So
to the other.
this is your height. Now I'm going to turn it so that it should roll. Then, so I want to measure that side.
Okay.
Uh, 1.2.
The diameter is also 1.2 centimeters.
Now,
And
she may read it a little bit differently. So there's going to be a digit you may have to guess on. So one person may see this just a little differently than somebody else.
and a radius is half the diameter. So half of 1.2 would be 0.6 centimeters. From there, you can calculate your volume using the formulas that are provided above. And the same with density. And density equals mass over volume. Okay.
And make sure that you use the appropriate units because mass is grams over milliliters. But since we are using centimeters here, our volume is going to be centimeters cubed. And 1 centimeter cubed equals 1 milliliter.
Okay. All right, so that's activity 1. All right, the last activity involved here has to do with the solutions that we created and our cylinders. Okay, so in activity 4, we're going to address, activity 3, we're going to talk about how our densities and our volume work together, which has to do with Archimedes' principle. So based on our calculations, we'd like to address it using displacement of volume. So in activity 1 and in activity 2, we want to predict whether the cylinders are going to float or sink. So looking at each of the different materials, we have a metal, we have a polyester or plastic, okay, and we also have
I believe it was acrylic.
acrylic.
It specifies on your materials list what these were.
Okay, so what do we expect the metal to do?
I'm going to predict it floats.
Okay, so
Now your predictions, they can be wrong, okay, but you're just guessing, so there's no right or wrong answer on a prediction.
okay, and we know that when you have different types of solutions, different things happen. So if our soda has bubbles, we know carbon dioxide interacts with our fluids. And you would expect something different to happen versus plain old water, okay? So you're making guesses based on what you're working with. So if we were to compare regular water with a 10% solution, do we expect the metal to float or sink? So Dr. Alaban thinks that the metal's going to,
I think it's going to float.
she thinks it's going to float. Let's see if that's true. Oh, okay. In this case, it sunk.
So my prediction would be wrong, which is perfectly fine. Again, predictions, no right or wrong answer. You're just taking what you know, what you've learned, and trying to make an educated guess.
Which is how theories are made. You make an educated guess based on intuition, what you've learned in science, and you either support or you don't. And the more support you get, the more theories come about until somebody comes up with a better theory. Okay, so now we have our acrylic here, and do we expect the acrylic to sink or float? I expect it to sink. Let's see what happens. Okay. Okay, here we go. That one sunk. Okay,
So I've got the last one here.
and it's best to remove your objects before you put the next one in because you don't want any interference with your other items.
And these don't weigh a whole bunch. Now there's some mass to this one. These almost feel about the same. So if this one's going to sink, I might go ahead and go, this one sinks as well.
Oh.
I would have gotten the wrong, we're not doing very good here. But that one obviously floated. So now I can predict, is the density of this object greater than or less than water? Remember, pure water has a density of 1 gram per milliliter at room temperature. So if this object is floating, what would you say about the density of this object? Is it greater than 1 or less than 1?
So these were our predictions. That was my prediction. And what did we actually see happen? So the aluminum, it was sink. And the acrylic, I said it was going to...
You thought it would sink.
Okay. And it turned out that this one would float. So basically, we had some, no, we got them all wrong, I think. But anyway, that's kind of what we did.
Yeah,
These were our predictions.
No right or wrong answer. It's just a guess based on what you've been seeing from patterns within the lab.
So you'll do that again with all of your solutions that you made up at the very beginning. What's going to happen? Now in activity 4,
and you might want to wipe these off just so that you don't contaminate other solutions. So if you're doing 10 to 20%, going from 10% sugar to 20% sugar, you might just have a paper towel and just wipe this off.
Okay. So now in activity 4, we're going to use flat soda, decarbonated. Okay.
Now I've had this one open for quite a while, so it's relatively flat.
And we're going to use the same procedure as we did in activity 2 to determine the mass of your 5, 10, and so on. And you're going to record the data in your table 5, which is this right here. Okay. So in activity 2, we have to go all the way back, and it says we're going to weigh an empty 50 ml graduated cylinder.
It still has a little bit of water in, so I still want to go ahead and take the mass of this and make sure that, you know, it comes up to 0. Sometimes I like to just take that extra precaution and just go ahead and tear it out.
So our mass of our cylinder is still staying about the same, so 30 grams.
But you notice each mass for these empty cylinders is different. There's some water there, but the masses are staying around 30, but there is some difference. So what I'm going to be taking into account is some of this is going to be that water, so it shouldn't affect my calculations because it's already being accounted for now.
Okay, so let's put 5 mils in.
Got a little too much. Make sure you use a separate pipette, so clean.
Put this away, though. We're done with that one.
So again, you want to read at eye level, and so right now it's at 5 milliliters. So 34.81. So it's not, for what I visualize, it says 5, but from what the mass is saying, it's not exactly 5. So there is, you know, some error, but it should be close to 5. You're not going to get exactly perfect. It can happen, but not every time.
And this is why we said it needed to be decarbonated or flattened. And so then you're going to calculate the mass of the solution, and then you're going to calculate its density by taking and doing 5 through 25. You're going to graph it using Excel and find its slope, and then answer these questions. Okay, that basically covers exploring density using Archimedes' principle, comparing it to calculating density using mass divided by volume, and determining which is more accurate. Thank you for joining us, and this is the end of the first one.
And we will see you on the next Future Labs. So good luck.